The project stage shown in this animation is located in Scotland on Dart Energy's Pedal 133 licence and shows the development of 4 well pairs, field gathering system and links into the local gas transmission system. Dart is required to obtain planning permissions, to have discharged any related conditions and to obtain all necessary regulatory consents before physical works on the ground can begin. Civil contractors will begin works constructing the access track and the first of the vertical well site locations. Firstly, we would look at the existing access arrangements and tracks to the site, and construct or upgrade these existing arrangements in line with our planning consent. We will then begin soil stripping the site in accordance with our planning design, and create a flat site that is suitable for the drilling rig. Soil from the site will be stored in bunds on the site, which ensure that the topsoil is appropriately stored for the site reduction, and also to provide visual and noise mitigation. A well cellar is constructed on the site with a concrete pad to support the rig. Geotextile membrane is positioned over the area of stripped soil, and aggregate is laid and compacted over the site, to a depth of approximately 300 mm, to support the drilling rig and associated vehicles. Generally, this process would be spread over a 2-week period to ensure minimal impact on the surrounding road network. Following the construction of the site, the drilling rig and site facilities will be brought onto the site over 2 to 3 days. First to arrive on site are crew changing rooms, mess facilities and office cabins. These are followed by the drilling rig. This is a truck-mounted drilling unit, so arrives to site on a truck and a trailer. The rig jacks up on legs, and then the mast is set up, followed by other rig components arriving on low loaders. Once this initial setup of the rig is complete, other equipment can begin to be brought onto site. We bring in the various pieces of mud pump equipment. Mud is just a drilling expression for any fluid that is being used to both lift cuttings from the hole and also lubricate and cool the drill bit as it does its job drilling. These fluids are closely regulated and provide no threat to the environment or aquifers. Other pieces that you would expect to see on a site are tanks containing water and also various cabins containing spares, drilling equipment and power generation equipment. All sites are designed to hold a small parking area, ensuring that there will be no parking of vehicles in the surrounding areas and road network. There is also a muster point and designated health and safety areas on the site. The vertical well will drill down through the rock formations to approximately 100 meters below the lowest target coal seam, at a depth of approximately 1,000 to 1,100 meters. The vertical drilling operation on average takes around 14 days to complete. The rig required to drill the vertical wells is typically smaller than that used to drill SAS horizontal wells. After completion of civil works on the second site, a second rig arrives to perform a surface-to-in seam well known as an SIS well. An SIS well site is constructed in the same manner as a vertical well. During this process, the rig drills down towards the coal seams. When the trajectory reaches the coal seam, it drills horizontally within the coal towards the vertical borehole previously drilled approximately 400 meters away. The SIS well will intersect the vertical well and will then continue drilling horizontally along the coal seam for up to 1,000 meters in the coal. The steering of the 6-inch wide drill head is controlled using electromagnetic technology, transmitted wirelessly to surface to the engineer. This allows the drillers to stay within the coal seam, which is between 1 and 2.5 meters thick in this area, using sensors detecting the roof and floor of the coal seam. This drilling process can be continued in other target coal seams at different depths using the initial SIS well bore to branch off from. These additional well bores will all intersect the vertical production well. The process of drilling a horizontal SIS well is approximately 90 days, working a continuous 24-hour drilling program. Unlike traditional mining operations, the coal is not removed but remains in place. Only the gas trapped within the coal seams is brought to surface. As there is only a 6-inch wide core removed from the coal, the structure strength is not compromised, and there is not movement in the rock formation above. Protection of aquifers is a very high priority for Dart Energy, and this occurs through several mechanisms, a couple of which are natural mechanisms and well-designed mechanisms. Firstly, the aquifers are protected by natural mechanisms through several layers of impermeable rock. Dart Energy conducts exploration in areas of interest to understand the stratigraphy of the region, to identify not only resource potential, but also depth and location of community aquifers. These aquifers are found near the surface, recharged from ground and rainwater, and are typically in rocks of good reservoir quality, high porosity, and highly permeable. Under this shallow aquifer strata are layers of rock which are highly impermeable, which means water cannot flow through them. These layers of impermeable rock provide a natural barrier between the shallower aquifers and the much deeper targeted coal seams. Interconnectivity of the aquifers will not take place through the several layers of impermeable rock. Secondly, well-designed mechanisms ensure that aquifers are isolated from the coal seams. DART adopts industry best practice by using multiple layers of cemented and cased holes. This effectively provides several barriers between the water and gas produced from the coal seams in the well and the shallow aquifers the well is drilled through. The cement and casing integrity are continually checked throughout the drilling process to ensure good well bore stability and isolation. This maintains best industry standards. Finally, the shallow community aquifers are protected during drilling by only using water to drill through the aquifers, until casing is set and cemented and properly tested. Only then, with shallow community aquifers cased off, would alternative drilling fluids, such as saltwater brines, be considered. DART would never use oil-based drilling fluids in any part of their coalbed methane wells. The processes provide vital protection mechanisms not only for the aquifers but also ensure well integrity and good resource productivity. As the drilling of an SIS well takes longer than a vertical well, the smaller rig, having drilled the initial vertical well, will have moved on to drilling the other vertical well sites. Having completed vertical well 2 and 3, the rig will return to each vertical well site to run completions for approximately 14 days. This includes running the tubing with the pump into the wellbore to pump the water and gas back to surface. The rig will then be removed from the site, only to return intermittently over the well's life, to conduct any workover or maintenance procedures to the well. A wellhead and production equipment will arrive on site so that well pumping can commence. At this time, a wellhead will also be attached at the completed SIS well. Once all production equipment is installed on the sites, their size can be reduced. In a pair of wells, the production of both gas and water is only produced at the vertical well site. As the coal seam is desaturated of its water content, natural gas is released from the coal and returns to surface through the annulus. As the water level decreases, the gas can flow more freely, and gas return levels at surface increase. The gas and water rise to the surface through separate pipes in a safe and controlled manner. As the drilling has been taking place, intersite connection service corridors have been constructed, containing a controlled gas pipe, water pipe, electric cable and communications wireline. The wayleave corridors link all the production sites to the gas processing site that has been constructed as drilling works have been carried out. This allows the transportation of the produced gas and water to the gas processing site, while also allowing exportation of electricity from the processing plant to the production sites to drive the production equipment. Following the drilling phase and installation of production equipment at each site, the site's size can be reduced. The vertical production sites will reduce to 1,500 square meters, about a third of the drilling size. The SIS well locations will reduce to 120 square meters, less than 1/20th of the drilling size. Following the installation of the production equipment, the well will be brought into production. For this brief period, the production site will have a water storage tank, generator and vent. Once the SIS and vertical wells are finished, the 4 pairs of wells will be in full production within 6 months to a year. Gas will be gathered and processed at the gas distribution site, where it will be dehydrated, mixed and pressurized before being added to the national gas pipeline. Water that has been collected from the production sites will also be treated to achieve standards set by the regulator and will then be piped to an agreed outfall location where it will be discharged under an appropriate license. The gas distribution and water treatment facility site will be built to accommodate production equipment for further expansion of the field and also allow link up to existing production wells in the area.